Hey class, this is Young, and this is the recording on SQL Developer, especially with all the join statement that I told you about. This is actually a new laptop I just bought just so I can do recording for the class. My previous was on a laptop break. Anyway, without further ado, so last topic we left off with creating constraint, which I believe I only show you primary key constraint. So for today, I'm gonna show you how to make a foreign key constraint first. Then using that, we can jump into the join statement. Okay. So first, make sure you connect to your SQL database. In my case, I already connect to them. So if you don't know how to connect yet, please either read the tutorial that I have created for you, and please install the tool so you can write your own SQL statement. Otherwise, if you already have it, watch the first two recordings on writing SQL. I believe since you're already familiar with ER diagram, meaning that you are now able to model a database. The next thing you should try to master is how to write SQL. You're gonna learn more tricks and skills as you have more experience. But for now, this will be sufficient to let you at least know how to write SQL. Alright, so I already created those two tables before, I'm just gonna drop them. Now I'm gonna make a table, right? Students. Table, I want to have student ID. It's an integer, it's gonna be a primary key. I actually don't wanna make primary key like that. I would then have student name. It's gonna be watch, or it's gonna be, I don't know, 40. Okay, set up. And the student gonna have class ID, integer. And now I'm gonna make student ID a primary key. Here's my student. There we go. This thing is so annoying. Now I'm gonna make a new table. Class. Hi. So very quickly, I just make a table called student, random, make sure they execute it. Boom, see that they execute it. Oh, and by the way, going forward, you're gonna have assignments where you have to turn in SQL statements. All you have to do is just copy whatever you have written here and put them into a text file or a .sql file and send it to me. I'll be able to run your SQL and see if they actually execute or not. Okay, that's how I know you're able to write a SQL query or not. You can just put whatever, even if you cannot get the query right, just send it to me so I can provide feedback for you. Anyway, I just made my table student. My table student has a primary key called student ID, and I have a column called class ID, integer. And actually, let me go ahead and drop this table. I want to add one more thing into it. Let me add school name, and it's gonna be a bar chart too. Give it 30 character. Alright, now I can create this table student created. Okay, so this table has class ID, and I'm planning to make class ID a foreign key to another table. What I would do, I would then create table class. I'm gonna have an item called ID. It's gonna be an integer, and it's gonna be a primary key. I'm just making it in different styles, so you know I can either make a primary key down here, or I can make a primary key right in my declarative statement. The thing is though, if you have a composite primary key, you cannot do it this way. You have to do it this way. Alright, so what you would do, you would just have comma separated and add more column into it. I already showed you that in my previous recorded lecture. Okay, class name for your 50. Okay, maybe give a school name too. Okay, the column name don't have to match up. Okay, so let's just call school. So for your 2 and so 50. Okay, now that it for this table. Oh, oops. Okay, so I have two tables, student and class. Okay, how would I then make a foreign key statement so that I can associate this column from table student references this column from table class? Okay. There's two ways you can do it. One, you can also have it in your DDL when you defining your table student. Or two, you can use the alter table statement like what I had showed you before. Since I've already created a table, I'm gonna go ahead and show you how to do it using just the alter statement. Alter table student. On way, right? Alter table, and then whatever table you want to alter, then what you want to alter. In this, I want to add, and instead of adding column, and I have to say add constraint because I'm applying a constraint toward this column. The foreign key constraint, also known as referential integrity, means that I cannot insert anything into table student unless whatever value I give it here already provided in table class. I will show you in a second. Okay, so at constraint, whenever you have the constraint, what people usually do is they name the constraint. So this constraint is going to be a foreign key, and it's going to be a foreign key from student to class. Okay, you have the reference key. Now you need the word references, and what you would need to do is add constraint foreign key references the column that you have, which is student, class ID. Add constraint. This is the constraint name, and then the actual constraint, which is going to be a foreign key. And then the foreign keys, you need this, open and close parentheses, then you put in whatever column going to be your foreign key, which is going to be class ID. And this class ID column going to reference table class column ID. When I run it, table student alter. Okay, let me go ahead and do this job constraint foreign student class. Right, whatever you need to have the alter as well. Alter table student job constraint. Remember, alter table is used to alter the structure of the table. In this case, you want to add a constraint, and you also want to drop a constraint, so you have to use the word alter. Let's insert some value. So now table student and table class are now associated together. A student may belong to one class, and the reference is defined in the class ID column. This class ID column is referencing this ID column from table class. So let me go ahead and insert. When you insert, watch what happens when I try to insert. The order of insertion matter. No. Insert into student ID, student name, class ID, school name, values, student ID, give it 1, student name, give it young, which is my name, class ID, give it 1, school name, KSU. Right. When I run this query, it will give me an exception. And it's saying integrity constraint parent key not found. Why? I'm trying to insert into table student. I'm trying to insert value into this column. and these are the value that I'm inserting. In class ID, however, I want to insert value of 1, but this column has a foreign key constraint, meaning this column, the value of this column has to reference an already exist value in table class, because when it go to table class, when it go to look for the ID, it did not find any value that matched the number 1, so it throws the exception. It's basically saying that I'm trying to establish a relationship, but the other end of the relationship was not created first. So I actually have to insert into table class first. I have to first make a class before I can add student into that class. Sort of like that. Okay, so now I want to insert into class. Remember, you can either tell it the exact column you want to insert into, or if you don't tell it, then whatever you insert in here have to follow the structure of the table. So in this case, ID is going to be first. I'm going to just make ID 1. Class name, database development. And school is going to be just KSU. Okay, so now I'm going to make or insert a record into table class first. Now I have a record in table class. I can then go back to my insertion statement for student and insert it. As you can see, it let me insert now because class ID 1 actually match up to a record in table class, and the value 1 from column class ID of table student to column ID of table class match one another. Okay. So let's see. Select all from student, right? One record, and then select all from class, one record. With that said, if I'm not trying to insert another student, right? Let's just get this student ID 19. It's gonna be Filippo 2L, okay? And I don't want it to reference a record of class ID 1. I want it to actually reference record where ID is 3. Still, let's say different school. Right? When I run this, it will also throw me an exception. Why? Again, it's violating the foreign key constraint, parent key not found. In table class, I only have one value, but that value specifically has ID of 1, meaning I can only insert into table student for all the students that will attend in the same class ID. This class ID 3 does not exist in table class, so there's no way it will let me insert it. Okay, so if I make this a 1 and insert it, it will work just fine. Okay, one row inserted. Now, student, class. Okay, one record. Okay. Let me show you real quick how to write your foreign key if you don't want to use the author statement. If you want to write it directly when you first define the table, what you could do is go back to table student, and all you gotta do, just gotta make foreign key, again column, so class ID, just go into reference, I spelled reference wrong, references the table you want to reference, which is class, and the column is ID. That is another way to make the foreign key reference. Okay, one quick call out: whenever you want to define a foreign key constraint, you must first create the other table first. In this case, this statement or this statement will not work if table class hasn't already exist. So the order of execution does matter. Because of that, I'm actually gonna move this above, just so you kind of follow. And I'm just gonna have the drop statement written here, since I may be dropping and refreshing this table over and over again to show more demo. But anyway, that's how you would write a foreign key. Okay. All right, now let's go to choice statement. So in my table student, I have 4 columns: student ID, name, class ID, school name. In my table class, I have 3: ID, class name, and school. What happens if I ask you to write a SQL statement that will show me the classes of all students? Right. So what you would do, if that's the case, you would use inner join. Right. What is a join? A join statement is basically, just imagine you're trying to build a robot. When building the arm of the robot, you're trying to look for some tool or wire, or even the arm has to somehow fit into the body of the robot. So there may be some value that you could use to join to make sure they all of the same attributes. That's a bad example, huh? Let's say, okay, the car. When you're trying to find tire of the car, you want to make sure the tire actually fit into the size of the wheel. So you may be doing like select all from tire, inner join, car where size equal each other, something like that. And if you do that, it will basically allow you to wrap the tire from a completely different manufacturer. As long as it fit, then you can use that. Let me just show you. This is why I prefer to write a lot of SQL statements, because practice makes better. A lot of time, theoretical concept may not make sense to you, but when you see it in practice, it will make a lot more sense. Okay, so then I would do select all. Right, again, from student. Nothing has changed. I want to select everything from student. But now I want to use inner join. Right, select all from student. Let me just select all from table. Your table. Okay. Inner join your order table. Okay. On similar column. Column from table 1 to table 2. So let's just call it table 1, and let's call this table 2. Okay, let's review the statement really quick. I want to select everything from this table, but I want to make sure whatever I select actually has a matching value in this table, and the key or the attribute or the column that I will use to define the criteria or the matching is in here. You will translate the above statement into select all from student, right? Inner join class on. Now this is the column, so class ID equal ID, right? A lot of time, remember, you can give your table an alias, similar to how you can give your column an alias. I would give an alias of S to my student. So I can, whenever I refer to S, I'm actually referring to the column in student, and for class it's gonna be C. All right, so S dot class ID equals C dot ID. What will this do? I want to select everything from table student where I only want matching record on the ID. If I run this, right, see the difference? I say select all, right? Now because I say select all and this is a join, it will give me all the column from the 2 table into this view. Remember, in table student I only have the first 4 column, which is student ID, student name, class ID, and school name. These 3 columns then, ID, class name, and school, actually come from table class. Okay, and The reason why I give back this record is because notice how the class ID here match up to the ID here. Right? So it basically saying, hey, this student match to this class record. So it pull rows from two different tables and assemble them into one single row in my result. Okay, similar for Philip Ho, right? Now, if I just want to simply select the specific column, I would then do, I care about student ID and student name, right? For the class ID, instead of displaying class ID, also I also want school name, okay? And now for class ID, I just want to display the class name. Okay, if I run this, right, notice how it changed. Now it's only display 4 columns because I only select 4 columns. But what I'm describing to the query is that the first 3 columns going to be coming from my table student. The next column gonna come from my student table class. Okay, now this is useful because see how I just went from one table student. I wrap in data from another table class in order to get this class name information. And the way I wrap it is by using join statement to join on a specific column. Alright, whatever column you join on, the value have to match. Okay. Now, you don't necessarily have to always join on the column where the foreign key relationship was defined. You can join any column you want to as long as they are the same data type. What I mean, you have to join integer to integer, varchar to varchar. You cannot join integer to varchar. Okay, you could, but you would have to convert either the varchar value into an integer value. So if your varchar is just say a number 2, then you can convert that number 2 into the integer. But if the actual textual value like 2 T W O written out, there are no way you can convert it to an integer, so your join won't work. Anyway, that's inner join. Inner join will only return result if the value match. So let me show you an example. I now want to do the same join, right? Also inner join class, but now I want to join based on school name. Okay, so school name with s dot school name equals c dot school. All right, because that's how I name this column in table class. When I do this, let's look at the data in these two tables. In table class, I have KSU, one record which is KSU. In table student, I have one KSU and one GSU. Remember, in the join, we only bring back record if they match. What that said is, when it join the two tables together, it's only gonna return result if school name matches. So in this case, because for my student, there only one student go to KSU, and in table class, there's only one record which is KSU. Only Young Ho will be returned by the SQL. Right, you get that? In student, when it joined by school name, Philip went to GSU, not KSU. That's why this query returned no result. Okay, again, inner join will only result if the values exist in both tables. Alright, get that? So that's inner join. Right, and inner join, you can write it like this. This is called explicit join. Later on in your career, especially if you're dealing with Oracle also supports implicit join. You can write the above query using this format. First, just give it all the table you want to join based on. then you send where s dot school name equals c dot school. This is the same exact query. Oh well, sorry. This will give you the exact same result as your explicitly stated out join statement. Right. This was the result from executing this query. Now I'm going to execute this query. Watch, the result is the exact same thing. Okay. This format is supported by most DBMS database management system. This syntax, the implicit join, isn't being supported by all their database system. It is supported by Oracle though, and the reason why it's work is because we're using Oracle database at the moment. Now for left join, let me first write this statement so you can see the difference, right? Sometimes a picture was more than 1,000 words to me. So student as, can't spell today. Student as left join, okay? So always select from whatever table you want to select from. Specify the join condition. Left join, inner join, right join, full join, whatever. Left join, and then whatever the table you have. After you have this, on join on what? I want to join on school name. Okay. Alright. Notice the difference. Alright, look again. In join, only return one record. Left join, return two record. But then these don't have any value. Why is that? Okay. Whenever you left join something, that means, hey, I want to display everything in table student. But I want to do a left join against table class based on school name. This means if any of the student has a matching value based on the school name, bring back that school information. If not, just don't display anything. That's what the left join does. If you do a right join, then it will be you want to display everything from your right, whatever table after your right join, right? Even if there's no matching value from whatever table you have on your left. Okay, so right join, left join, full outer join, they all work the same. Full outer join will just display all the record in both table, and for whatever record don't have a matching value, the information on the table that you want to further get the data from will just display null. All right. So for example, select all from student net full join class C on s dot school name equal c dot school. The reason why this return the same value is everything in S, which is only 2 record, and everything in school, which is also only 1 record. I would only, in class only database development. So it did not pull back anything. Now, real quick, let me insert into class very quickly so you can see the difference. ID is just say 9, class name, software system requirement. Then school, let's just say, what's some other school? What's that? Okay, UGA school, right? Run this. Okay, now first run the left join. Okay, left join still only pull back this value. It did not pull in the new value I created in class Y because its left join will prioritize whatever table on the left of the left join, which is student. So every record in student will be displayed, and it will only display information for whatever record from class if this value match. In this case, even though in table class I have 2 records, it's only display KSU because I only have 1 matching record KSU in table student. If I run the full join though, look at what will happen. In this case, first it displays everything, right, from student, and this is the matching value from class. But now it gotta display everything from class. This is everything from class. And for this, database development KSU has one matching record. Software system requirement or UGA score don't have any matching record, so this is displayed as no value. Alright, so that's the difference between inner join, left join, full outer join, and right join. Okay, so this is pretty much how join statement work. Okay, if you want, you can actually join more than one table, whatever you want. Simply have the join statement continue. So in here we have inner join, and then you can inner join what? Let's just make an imaginary table school, right? Just call it SCH school on what? Let's just assume on class school equal SCH dot school. Right, you can do this, and now it will pull back information from 3 tables for you. Okay, this select, because the join will pull back record from 3 tables, you can select any column from those 3 tables for display purposes. Alright, let me just remove this. Assuming for this, right, let's just say I only want to display student name. Sorry, S. The S is the alias for student, and then class name. Here, only those 2. Okay, so Young has this class. Philip don't have any class. Okay, if you want to get rid of Philip, or well, actually in this left join now, remember the criteria filter. You can actually have your where. In your where you can specify condition like where the school name have to be GSU, for example. If you do this, it's not gonna pull back anything, right? Because GSU doesn't exist in table class. Okay, so class, let me just write it. Okay, but if you do KSU, see how it's only pulled back Young? Because you filter, right? You want to join based on school, but the school name has to be KSU. Okay, and then you can where this it with school has to be that, and student name just have to be, let's just say Philip. Okay, nothing fullback, because this condition, the join will work the first join by school name, then it filter that result for KSU, which when it filter the result by KSU, I'm just gonna highlight this. Okay, let me move this down. Okay, so first join by school name and only display the result for school KSU. I have one result. Now from the result of the statement, further filtered by student name. Right, so let me bring it back. Filtered by school and by student. None of the record exist, right? Cool. Alright, so that's how you make foreign key. That's how you do inner join, full outer join, left join, and right join. Okay, I will make, or maybe I email you what you should be studying for your test too. Yeah, so I'm only a part-time instructor. I really don't have that much power. I honestly didn't want to give you that many tests. I would prefer to give you more assignments so you can improve on your SQL skills, but it is academia requirements. So I do my best to give you a good review of the test so you know what you should be studying for. But other than that, please continue to practice your SQL. I cannot stress on how practice will make perfect. The more practice you put in, the more proficient you become with writing SQL. Okay, all right, that's all I have. Thank you. Bye bye.